So, hi everyone. I am Parampreet Singh, and as you all know, I have been taking MLP sessions, machine learning practices sessions this term. I have MLP course as well as MLP project also. Uh, like I am doing programming since past 4 years, and ML past almost 2 years. So, uh, majorly I know all the ML concepts which are covered in MLP course mainly. And so just to help you all, I'm taking up this session and showing you the live coding, live exact implementation with the mathematics behind each and every algorithm we do. So let's start. And today we have like our 15th session, which is on mainly classification. All right. So classification is another type of problem, just like regression in machine learning. And we will mainly first look into deep dive into logistic regression, which is a classification algorithm. And then um, some of the classification evaluation metrics, like accuracy, precision, recall, F1 score, and the main thing which is like to evaluate all these metrics, the main confusion metrics. All right. So we will mainly go through all this stuff, and if we have some time, so we will look into other algorithms as well, the KNN decision trees, and um, like not in the deep, but some a little go through about these algorithms. Okay, so let me zoom in first. So is the font size clear to you all now?
Yes, it is.
Okay. So let's start. And yes, one more thing, as like I'm recording this session and I will upload the recording in my YouTube channel, which is here, so you guys can subscribe to it and like keep the notifications on. I will upload the session by tonight, like after ending. It just take 1 hour of pre-processing, then I will upload it. So uh, let's start. Okay, let me open the whiteboard as well. All right. Okay, that is good. So let's okay, let me add the data set as well. So as this is a to like we will go through the classification algorithms mainly. So we will mainly obviously we need a classification kind of data set. So we will use Titanic competition data set. All right. So like as there are Kaggle host many competitions, so Titanic is one of the competitions which is majorly famous to to practice our classification, mainly our ML skills, as well as mainly to work on classification kind of problems. So I have just copied this title from here from the competition link page, and I have pasted it in this URL. And the first one is the dataset. So I'll just click on this plus button, and the dataset will be added into my input source here. Okay, so it has mainly three files: train, test, and gender submission CSV. So mainly what we have to do is we have to this is a Titanic um, prediction data, sorry, Titanic competition. Mainly we have to check like who are survived or not, or okay. So mainly this is the dataset. So let me run this cell once again, so you can see we have these uh, files here. So let's do the first step, which is basic to load the dataset. All right, so I'll just copy this path from here, the train.csv, and this is my dataset. So okay, it is loading. Okay, so this is the dataset, and if we look into the shape, so it has like only 891 rows and 12 columns. Okay, okay, not the last column, the survived column. This column is the target label. All right, so we have to check whether a whether a passenger has survived or not. Okay, so um, now what we do is simply just a little bit ED. Um, so if we check with this dot info, so we can see like there are a lot of columns of various types, float, integers, and objects. So mainly like for this purpose I'm not doing all the any kind of pre-processing or and all. So I will simply select all the numerical columns, all right, to like move forward to the main ML algorithm. So is that fine? um, is it
Bro,
fine?
maybe take two categorical.
Okay, all right, so we have five categorical
See,
columns, so I'll
one
uh,
nominal, one categorical, like that.
okay. So okay. So I'll take the categorical column as well. So okay, just before that I'll check are there any null values in each of the column. So all right. So we have null values in age and cabin. So in cabin we have a lot of null values. So it's better if we like do not consider that cabin column, this one. Okay. Like out of 891 rows, we have 687 null values. So that is almost 80% of the data set. Um, right. Okay. Sorry. Divided. Yeah. Okay. Yeah. 77% of the samples are null values of cabin column. So we'll just ignore that column, or you can simply say we are just dropping that column. All right. So let me just simply select all the columns first. Num columns. Num columns, I'll simply do something like this: gf.select dtypes, and here I'll pass exclude object simply. It will basically exclude all the object columns, and dot columns will give me the numerical columns. Um, okay. I think we should do this step further. So okay. Let's first do one more thing. Let's import the train test split from sklearn dot model selection import train test split. All right. So I'll just simply split the dataset into two parts: training and validation. Okay. And for that, first I need to define what are x and y. So the number, the features, and the rest of the column. So I'll simply write df dot drop column survived. As survived is the target column. All right. And then y equals df survive and dot copy. Simply I'm just copying, like this is just a good practice to copy, so that's why. Okay, I have to write column. So we have x here and we have y here as well. Okay, so y is just a 0 and 1. 1 represents survive, 0 represent passenger does not survive. Okay, then okay, so now like we should select the columns. Data frame object is okay. Select d types. Yeah. Okay. Yeah. Okay. Before doing selecting the column, so let me simply split the data set. So x train, x valid, y train, y valid. Okay. In what ratio, like, do you recommend to split it? Like, any ratio? Anybody? In what ratio should we split it? Like 70
with
to 30?
30%.
Okay. So test underscore size 0.3. I'm just keeping random state to some value, so we'll have the same samples. Okay. So just it is splitting, and here you can see the shape of x train and x valid. Okay. Now the main thing comes here. So num column, so we have all the numerical columns here, the passenger ID. Okay, so we can like take the passenger ID as the index, right? Because that is the ID. we should not consider this as a separate column. I'm just running this all this once again. Yeah. Now like as you all have said, okay, so if I select the object columns only, so we will have names
If
x.
we select some column as index, then that column will be
That
acting
will
as
be considered as an index, and that will be removed from the data frame mainly, like that
data.
will be not included in the columns, right?
Okay.
Screen is not visible.
No, we can see.
Okay. uh, I think there is some issue from your side. You rejoin. All right. So now, okay. So we have like various and these columns, object columns, categorical column. So cabin, we saw cabin has like a lot of null values, so we won't take it. So let's take the embarked and like let's take the names x embarked. All right, or in fact all the columns except the cabin, so that will also good. So cat calls and um okay, these are my categorical columns mainly, so I'll just like let's get rid of the cabin column at, from the starting itself. So df dot drop column cabin in place true. So this statement you all understand, right? This is just a basic, like I'm setting in place to true, which means I don't have to reassign it. So now we have like we are left with 9 columns. Okay. So these are like various columns. So now just a little bit pre-processing also we have to do. So I am importing from sklearn dot pre-processing import um, in pre-processing mainly ordinal encoder, that is enough, and from sklearn dot okay, I want the imputer as well to fill in the missing values, so simple imputer. And just one more thing, like I'm importing the pipeline as well, okay, so that we keep the all the things in a certain manner, and the column transformer which will help us in the pipeline. Okay, so now let's start. So we have like these columns, numerical columns and the categorical columns. All right, so I'll just make a simple column transformer, column transformer, and I'll define some basic steps. Okay, so first is uh, num imputer mainly for the numerical imputations. Simple imputer, I'll define the simple imputer. By default the strategy is mean, right? So and I'll just pass in the num columns here. Okay, then cat transformer I can write. Why transformer? Why not a single imputer? Because like we have to transform the categorical columns into numerical values, right? So I'll define a pipeline inside it. Like how? Um, okay, pipeline, and in the pipeline I'll have two steps. One is the imputer mainly, okay, for the categorical columns. Simple
With the
imputer.
screen is not visible right now.
Sorry.
The screen is not visible.
Is the screen visible to like rest of you?
It's visible.
Okay. Uh, you can rejoin. Supernova mathematics supernova. You can rejoin, and then I think it will be visible. Okay. So I'll set the strategy as most frequent because of the categorical columns. Okay. This is the first step, and then the second step is like okay. I have to set it like this. Okay, then the second step is mainly transform ordinal encoder. Okay, odd underscore encoder, and I'll simply encode the values ordinal encoder, and here I'll simply set handle unknown as okay I forgot parameter values. Handle unknown, use encoded value, yeah. And then I'll set some unknown value. Okay, so handle unknown is use encoded value, which means like let's suppose there are 100 names, okay, in the complete data set, and I have divided the 100 samples into train and validation. So if I do fit on the train, then I may get new names in the validation set. Okay, so I'll just encode those new names with -1. Okay, so that's what
Could you
these.
explain again this handle account part means what we are doing actually by using this?
Okay, just a minute, let me write it once. Okay, um, unknown value as -1. All right, here I have like simply defined the pipeline. Now just one thing left, which is the cat columns. Okay, so this is the main transformer. Is this clear to you all, this transformer? Like for the numerical columns, I am simply imputing the mean value for if we found any kind of missing value. Okay, and for the categorical columns, I'll first impute the missing values with the mode that is most frequent. Okay, and then I'll encode them with the ordinal encoder. So these steps are clear. Um, if they are clear, like you can uh, like give a thumbs up.
Yes.
Okay, so okay, so this handle unknown, these values mean, so if I like um, all right, it is having some issues. Okay, just 1 second, guys. Let me share the entire screen. Okay. Skelly Pro. Okay, so we have this parameter, right? In that ordinal encoder, but this too is, let's suppose we have okay, that is very big. That is in fact big. Okay, no worries. So we have, let's suppose, 100 samples. The stroke is very big. Okay. So we have 100 values. All right. Let's suppose we have 100 samples. Okay, m equals 100, and we have a name column, just like here. If you see, we have a name column. All right. So let's suppose each sample has a unique name. Like each person has a unique name. Let's suppose this is what information we have as of now, and I have splitted the dataset into two parts. The training and the validation set. Okay, so training will have 75 samples and the validation will have 25 samples. Let's take this example as of now. Let me paste it. That is okay. So what we will simply do, if I like mainly the main general ways, like when we encode them for the with the help of ordinal encoding, each value will get some integer, right? Let's suppose we have 75 unique names, so for each name we'll get some value 0 1 2 3 4 5 and so on till the 74. All right, so this is what mainly ordinal encoder do. Then when we transform the validation set, which is this set, okay, then we will get like an error, which means the names are not in this category, like to transform, because these are new names which does not exist in the training set. Okay, so that's why using with these parameters, like handle unknown means if we find some unknown value which we for which we does not have any kind of mapping, we will use some encoded value. And what that encoded value, value can be defined by this parameter, which is this unknown value. I'm just setting it -1 as of now. You can in fact set it to 0, 1, or any kind of integer, because we need the transform data set in integers. All right, so I'm just setting it to -1. You can in fact set it to 0 as well. Okay, so that is the purpose of using these two parameters. Is it clear?
Oh, yes, yes.
Okay, so this is the transformer, and now I'll simply transform my data set. Okay, I'll write transformer dot fit underscore transform, and I'll pass exchange directly. So it will transform the data set. Okay, and I'll write exchange and tf and xtest, oh sorry, not test, xvalid tf transformer dot transform. Okay, xvalid. So now I'll have the transform data set. Okay, and of course, like this is in the array. That doesn't like do anything much. That is all right. Okay, so we have this data set as of now, the transform data set. So let's move forward now. Now comes the main thing, which is like classification algorithm. So let's first start with the logistic regression. Okay, so anybody knows what is logistic regression?
In the name, there is regression, but it is classification algorithm only.
All right, and like anything else, like uh, the function definition, like the mathematics behind it, or anything related to it, let's say the loss function, or maybe the range of the values it gives, anything? Okay, so anybody knows why we call logistic regression a classification, like it is a classification algorithm? Why we have a name like logistic regression? Why not a logistic classification and all? Like I know it's a theory part kind of thing, but that is like you can say this is important to understand. Okay, so are you all aware with the linear regression? If yes, you can give a thumbs up. Linear regression, the main algorithm which is mainly power all the AIMLs algorithms. Okay. So um, let's move on to here. Okay. So um, okay, the stroke is very big. Now it is fine. Okay. So the thing is, in the linear regression, okay, so I have to write the complete. So I'm just writing R for regression. Okay, so the equation for linear regression is this, right? Wx plus b. Am I right? Guys, you can like respond with the,
Yes.
if anybody can speak. Okay, so this is the equation for the linear regression where W are weights, and then b is the intercept or bias, which we can say. All right, so and x is of course the data, and we get some value which we call as y hat. Okay, the actual values are considered as a y, and y hat considered as the predicted values, right? For that target label y. And now like just following the linear regression, we have another algorithm, logistic regression. Okay, okay, before going into that, just one more thing, classification, like what you all know about, like what do you guys know about classification, like anything? What is a classification problem?
Classifying things based on certain category.
Right, certain category or any some discrete values we can say, right?
If you're in this region, like
Yes. Let's suppose like okay, majorly like we have mainly two kinds of problem. Either one is regression, okay, then the classification. This is mainly in supervised learning, okay. Regression is for the continuous variable, right? Like we have to predict house price, how much rainfall or the temperature or anything, the weight or anything like that, okay. The continuous variable, like where we may have float values, we cannot count the target labels mainly, like they have uh, there are a lot of values and the range is infinite mainly, okay, we can say. Then we have a classification type of problem which basically handles with the discrete values, okay. Discrete values has some range as well, okay. So I'll just simply give you a simple example. um Mainly like let's suppose we have a picture and we have trained some model, okay. We feed in that picture and the model gives us 1 or 0, okay, two values. And what the picture is, you can like imagine there is some cat, okay. Forgot about the diagram. So the pictures we are feeding into the model are of like pictures of cat, okay. So we have to like there are some pictures of cat and there are some pictures of dogs as well, okay. So dog and cat pictures we are feeding into the model, and the models like the purpose of the model is to like predict whether the picture is of a cat or a dog, okay. If the picture is there is a cat in the picture, then it will give us 1. If there is a dog, then it will give us 0, okay. So this is one kind of a classification problem. Like I'm just giving you some example. Or let's suppose like we all use Gmail, right? If not in like general purpose, in the IITM student mail ID, right? So Gmails, like we get some mails marked as spam, right? How Gmail identifies it? It in the backend it has some like a machine learning algorithm running, which mainly like whenever we receive a mail, okay. Let's suppose we receive a mail in the mailbox, okay. Then in the backend, Gmail basically run a ML model and check whether the mail is spam or not spam, okay. So like as machine learning works in numbers, so we can identify spam as 1, not spam as 0, okay. So if the mail is a spam, then basically Gmail marks it as a spam, right? And gives a warning as well, some maybe sometimes. And if it is not a spam, then we mainly get the mail into our general inbox, right? So this is also like one example of a classification kind of problem. And okay, in the classification there are
Parameters identify the Gmail to be spam or not.
sorry.
What are the parameters that Google use to identify a receiving email to be a spam or not?
Okay, I'll just give you a simple overview of it. Like, let's suppose we get some mails, like, uh, let's suppose there are some fraud mails as well we got, like, congratulations, you win a lottery, something like that. Okay, so it identifies some words. Let's suppose if some mail has a lottery word, okay, so that means this mail have a high probability, like have a high chance that it is a spam. All right. So generally, like if people won a lottery, they don't receive some kind of a mail from anonymous mail ID, right? If they don't have some mail in the contact list, or in fact, the Google, I don't know the exact parameters what Google use, but it may check the body of the mail, the metadata. The metadata mainly includes like uh, from where the mail received, like the two like the receipt, okay, the Gmail from okay, sorry, the mail ID from where we received the mail, and other things like the IP address and all the other parameters, the other metadata. And it may like and it uses those parameters and maybe do some kind of feature engineering and all, and then basically checks at the end whether some mail has a high probability of like being a spam or not. And by that, like after that probability we can set a threshold. I'll just go into that deeper just in a moment. So this is like a simple classification example I'm showing you. In classification mainly we have like three kinds of problems. Okay, the first one is binary, then we have multi-class, okay, and then we have multi-label. All right. Binary is the same which we have just given you example, spam mails, or let's suppose whether there is a cat or a dog. Basically, uh, dog. There are mainly two certain outputs, right? Cat versus dog. Okay, so that comes under binary classification stuff. Then we have multi-class classification. In multi-class, we have like when we have in the target label we have more than two values. Okay, let's suppose the food rating. Okay, so let's suppose there is a restaurant which mainly uh, basically serves of they have some data like of each of the respective food item, like the food which they have given to the customers, and at the end like customer give them a rating from ranges from 1 to 5. Okay, so that you can identify as a multi-class classification problem, like where you have like given where you have some data like regarding the food and all, and that and the recipe as well, the food recipe, and at the end you have to predict like how much rating has been given to that food, like whether it is 1, 2, 3, 4 or 5. You can see like here we have mainly 5 classes to predict, right? In one label, which is y, right, the rating. So this is multi-class classification problem. Okay, is this much clear to you all, these two things?
Yes.
Okay, then the last one, not the last one exactly, the third one, which is multi-label. Multi-label means, let's suppose we have various labels. Let's suppose we have some human column, okay, and a bird column and an animal column. Okay, and in bird we have various kinds of birds, uh, you can identify as many birds as you want. In human, let's suppose we have male and female values only. Okay, and in animal column we have, let's suppose for the sake of example, just cat and dog. Okay, so we are given a picture, okay, a scene, a scenario, any kind of, and there are various things. So some car is there, okay, and some human is there, and they have a pet also. Okay, so we have given a picture into the model, and the model has to predict like various things in it. uh, Three labels mainly. Okay, uh, in three labels. First one is the human, then second is the bird. Okay, then there are some birds as well in the sky, and the animal. Okay, and in human, like they have to first identify whether there is a human, and if yes, if there is some human, then then the model has to identify whether it is okay. So mainly, like if we go into the in this stuff, human, birds and animals, yes, bird, sparrow, crow, pigeon, etc.
So
So
it will become multi-label, multi-class.
yes, it will label okay, just for the sake of multi-label, the model has to identify whether there is a human and or bird or animal. Okay, there may exist two answers or only one or maybe three as well. Okay, so like let's suppose we have some kind of target label y as like this. Okay, um human, animal and bird. Okay, and we have given some pictures 1, 2, 3, 4 and so on, and one represent there exists some human or there exists at label, and 0 represent there does not exist at label. Okay, so that kind of, like you can say, this is mainly multi-label classification where we have to identify multiple labels. Okay, So this is third kind of a classification problem. Then the last classification problem which we have, multi-label multi-class. Okay, the same example I will take, which we have right now, that human, birds and cats. Now let's suppose in this the table which we have, the target label y, we have like more than two values mainly. Like in the human, let's suppose there are some values like -1 represent there does not exist a human, 0 represent the human is a male, 1 represent there the human is a female. Okay, then in animal there is no animal or a cat or a dog. Okay, then birds, there is no bird, there are no birds mainly, or there is some crow or sparrow, pigeon, etc., and so on and so forth. Okay, so this is like when we have to predict in multi labels, as well as like in each label we have multiple classes. Then the problem becomes multi-label multi-class problem. Okay, this is another type of a classification problem. So mainly we have these four types of classification problem. Are all these clear to you all? These four, like,
Yes.
okay. Now like we will first like mainly take the binary classification problem. Okay, just to like go through the complete machine learning algorithm, which is the logistic regression. So uh, let's get back to the logistic regression algorithm. Now in linear regression we like we predict some continuous value, right? That y hat is some continuous value. Now if we take this wx plus b, that direct function, okay, and let's call this function value as z. Okay, z, not y hat, like for the logistic regression. Okay, fx equals to z, whatever value we get via this equation we will store it into z. Okay, then there is a function, mainly in the logistic function we call it as a sigmoid function. All right, and that sigmoid function is okay, yeah, the sigmoid is basically represents with the same this variance symbol. Okay, that sigmoid function, or you can also, if I write it, this is the function, and the definition of the function defines something like this: 1 upon 1 plus e raised to the power minus z. Okay, this is minus z, not minus 2. Okay, so this is how sigmoid function is defined, and this sigmoid function what makes this linear regression as logistic regression. How like the e, basically e raised to sorry, this function, if you plot the graph of this function like in some, in any range you can say. Okay, let's suppose we have the z values here, and this sigmoid function plotted here. Okay, then we get some kind of a graph like this. Okay, if you plot this in the graph you will get the curve in this shape. Okay, let me show you as well. If I check in the Desmos, so the function defines something like this: 1 upon 1 plus e raised to the power um, minus z, right? And in the z I'll add okay, that is yeah. So okay, mainly like, okay, if I can I increase the values set, and let's say 500 maybe, as of now. Okay, it is not f of x, f of z. Okay, I'm not able to plot it, sorry for this. Yeah, so mainly like even if you see the sigmoid function, like if you plot this function, okay, then you will get some graph something like this. All right, And what this mainly graph represent, like for each value of z, and z, you know, z is the same f of x, which is basically this equation. Okay, if you plot this equation, that is wx plus b, for various w values, you will get this function. Okay, and this mainly function has like in the range of this function is 0 to 1, yes, not -1, yeah, 0 to 1. And like this basically predicts, you can say, the probability of like some event is happening, which we in statistics we can say, right, the probability of some event is happening. So it gives the output in the range of 0 to 1. All right, and we can set some threshold. Let's suppose we are let's take a simple example, like uh, आज like whether today will be a rainy day or not, whether like today there will be rain or not. Okay, so if there will be rain, let's suppose I represent x and 0, these values, like for some days we have some data of, let's say, for month, and 0 represent there will be no rain, and x represent there will be rain. Okay, so if I plot some values, okay, xx something like this, all right, these values you can say mainly, okay, not in different, in the y values itself. Okay, so these values and some 0 values here, okay, x and 0, x basically you can say 1, and 0 you can directly say 0. Okay, so this sigmoid function basically, the curve is something like this. Okay, so if we simply set some threshold value, let's suppose say 0.5. Okay, this threshold value something like, okay, sorry for that loopy line, yeah, this threshold value. So we can like, okay, uh, whenever like we run this linear regression algorithm, and after that we basically calculate the output of we take the output of this linear regression algorithm, and then we put in the output of that algorithm into this sigmoid function, that is the logistic regression algorithm. We get this graph. All right, and after this, whenever we plot this graph, and like this graph is in the range of 0 to 1, which we can say the range of probability is also 0 to 1. So we can simply set a threshold, let's take some any value, like for here 0.5, and we can simply say, if some value, like let's suppose for some example x0, okay, for some example x0, if the probability is greater than 0.5, then it means that that day will be a rainy day. If the probability is less than or equal to 0.5, then we can say then there will be no rain in that day. Okay, so this is how mainly we use the sigmoid function. So this is mainly underneath the mathematics, the definition behind the logistic regression. So
How
this,
we will be determine the threshold value for
that
sigmoid
threshold
function?
value is by default we take as 0.5, and that we can consider it like based upon the classes as well. Like let's suppose this, I have taken some very simple example. So like earlier in last year I worked on a problem that is heart disease prediction. Okay, so that problem is like we are given some parameters: age, sex, cholesterol level, their blood pressure, their sugar level, and chest pain, and a lot of parameters. And based on those parameters, we have to predict whether the patient has a heart disease or not. Okay, so we can like, I started with this logistic regression only. I have plotted this logistic regression something like this. um, okay, the sigmoid function here, and the one value is here, 0 value is here. Okay, so I'll simply represent it by dots normally. Okay, and some one values like this, um, and mainly, okay, rather than dots I'll simplify this. One I will represent with the x, and 0 I will represent with the symbol 0 only. All right, so we have a lot of zero values, you can say. Okay. Okay, not in that graph mainly. And then here also, okay, let's suppose we have some, okay, these zero values and some x values here. All right. And okay, just one thing, sorry, that threshold is okay, this is the decision boundary. This is basically this is the threshold mainly, wherever this decision boundary intersects, okay, on basis of that we get some threshold value. Okay, this value basically separates the zeros, like all the values which are before this value, these will be considered as 0, and after this, these will be considered as the x, which is the 1, that is the there will be a range. All right. So I was working on this heart disease prediction, okay, this problem, and what I have was, let's suppose like this is some kind of a rare problem, we can say, right? If we have a data of, let's say, 1000 patients, so out of let's suppose out of those 1000 patients, we only have 500, okay, not 500, sorry, we only have 50 patients which have heart disease, and the rest of 950 patient does not have the heart disease. Okay, so normally like if we simply plot the sigmoid function, we get something like this, right? So this will be the sigmoid function. All right, and at like at 0.5 it will be like at the at most center, right? We can say after 0 point, if we increase the value, if we increase the threshold, then the value will be more inclined towards right side, and if we decrease the value, then the value will be more inclined more towards the left side, right? So let's suppose we have only 50 samples. The data, the target label y, we can say it is imbalanced, right? Can we say this data is imbalanced? um okay, anybody? Okay, okay, let me,
I think this is balanced.
yes, this is imbalanced. Why? Because like you can say the proportion is very different. Generally we have like proportion almost around 40 to 50%, or let's say 60% in fact. Okay, normally, in normal cases, but this is some kind of a rare problem if we which we are working on, and we have like a rare disease, something like this, that heart disease. All right. So the proportion is very different, right? Only the 5% of the people has the heart disease, and rest 94% does not have the heart disease, right? So this is the imbalanced data set. Am I right?
Yes.
Okay. Now if we like simply set, okay, if we check in some zero values here, okay, for various z values we are getting zero values. You can consider all these points at zero, line towards zero only. Okay, so we have a lot of zero values, and we have very few x values, which represents the patient has a heart disease. Okay, so if we simply set the threshold as, let's say, 0.5, okay, this as a threshold, and this basically makes a decision boundary which intersects, okay, can I make, yeah, this is a kind, okay, let me, yes, so this is a kind of a decision boundary which we can say. Okay, we have, all right, so based on this decision boundary, we can say all these samples, okay, we can simply say all these samples, okay, only these we can identify as like these patients which have like these Z values, they do not have heart disease, right? And after that decision boundary, like all these samples as well as these samples, these will be identified as like patient has a heart disease, right? Based on this 0.5 threshold value. Am I right? We can say this. So
If the threshold is 0.5, then the number of patients below 0.5 also have heart disease. It means the total number of 500 people have heart disease.
Not exactly 500. Okay. This, okay, you have not understood this one. So see, this function has a range of 0 to 1. All right. So in 0 to 1, this gives a probability. All right. And on that probability, we set a threshold, and based on that threshold, we set a decision boundary. If I show you logistic regression decision boundary. Okay, we don't have a good graph here. Uh, yes, something like, okay, this is well versed. Yes, so this is the same graph, which almost the same graph you can say. Okay, so here you can see like this is the sigmoid function, right? This blue curve, right? And we have a threshold of 0.5. This is the threshold. After that, we have like you can see this is the decision boundary at value 40. Okay, all right. So whatever like let's suppose this we have the z range from 0 to um, okay, from 0 to 100. Okay, the value of z, and this basically at, let's suppose, say 50. So all the patients which are getting the z value, which is wx plus b, as less than 50, we can consider those patients does not have heart disease, and all the patients which do not like which are getting the value of z above 50, we can set this like we can consider them as like they have the heart disease. All right, based on this decision boundary. Am I right?
Okay, I understood.
Yes. So like by this decision boundary at 0.5, you can see like a lot of patients who does not have a heart disease, they are being considered as like they have a heart disease, right? And this is not a good model which we can say, right? So like heart disease gives like मान लो of course I don't want कि ऐसा कुछ हो. Generally, like if you get some serious illness, some serious disease, like let's say heart disease or not, and something like that, that will cause you a lot of problems, like in financial terms, in mentally as well, right? As well as physical terms as well. Like in mentally, some people might get like trauma as well. So a lot of like important things are here to be considered before telling a patient that they have a heart disease. So we cannot set a 0.5 as a threshold value for this kind of rare problem, where the consequences will be like very harsh, right? If the model predicts the patient has a heart disease and treatment start ho jata hai, and in reality they do not have heart disease, and that treatment may cause side effects to the patient, right? To the patient's body. So बहुत सारी दिक्कतें हो सकती है. So that's why in these kind of rare problems which we are like in these kind of rare problems which we on which we do the ML modeling, and mainly in logistic regression, we basically, if we are using logistic regression, what we do is rather than setting, okay, where is the eraser? Yeah, rather than setting this as the decision boundary, the 0.5, what we do is we set some other decision boundary, like some higher value for the probability, something like you can say 0.9. All right. So if only if this function gives the value above 0.9, then only we will consider that patient has a heart disease. All right. So if we set this as 0.9, you can see like at this 0.9, that threshold is intersecting the function at here at this point. And if we plot the graph, like sorry, plot the decision boundary, and let me set it here. All right. Now you can see like the basically it is now the model will do better predictions, right? How, like if you see, now all the left values from this decision boundary will be considered as like they do not have vertices, which means these many. Okay. All right, and these as well as these. So again, like we have the some more, like some amount of patients which are being considered as like they have heart disease, but in actual they do not have. We can in fact handle this further, like by setting some more threshold value, let's suppose 0.95 or 96. All right, so this threshold value is significant when you have a imbalanced data set. Okay. That data set, basically mainly this thing, you can check the proportion of the values. By that proportion you can identify whether the data set is imbalanced or not, and basis of like how much data set is imbalanced and what values we are getting, you can simply like okay, you can simply set the threshold value according to that. Okay, so based on those threshold value, the model will predict whether the patient has a heart disease or like that, whether that thing exists or not. All right, so this is like the main intuition behind logistic regression. Is this clear to you all? I know थोड़ा सा ज़्यादा है. If you watch this thing again, आपको जो है clear हो जाएगा. Because like now we have the concept of probability as well.
That uses the logistic regression function.
Sorry.
Does every AI model use the logistic regression function for health modeling?
No. Not. We have a lot of classification algorithms. Logistic regression is one of them. Okay. And why I'm like mainly teaching you the logistic regression at first, because mainly two reasons. We have covered the linear regression. All right. So it will simply like we already have the base if you are watching my sessions. Second thing, logistic, the mainly the understanding is simple. I know there is something like there are some new concepts like threshold, decision boundary, and the probability, and especially this function definition. But yes, the logistic regression is much easier to understand compared to some other algorithms. Let's suppose the SVM. Okay. Uh, some are in fact easier than logistic regression, but just because like I have already covered up the base with linear regression, so I'm consider taking up this as well. We have a lot of classification algorithms. All right, not only logistic regression. uh, we use like naive bias, um, the main, which I one more like support vector machine, which I have just told you, the KNN, k nearest neighbors one, and of course the tree models. The tree models are everywhere, like decision tree, random forest, and as well as the boosting models like XGBoost, LGBM, light gradient boosting, and a lot of these models. Okay, so we have a lot of algorithms. Logistic regression is one of them. So like till now the intuition is clear to you all, like how logistic regression basically works. Is this clear to you all? The rest of you? All right. Like so let's move forward. It's already been 7:50.
How can we minimize the errors in the model,
Yes,
in the
I'm
task?
going into that only. Like okay. So um just 1 second. All right. Now in linear regression, what error function do we use in the gradient descent linear regression, which is to SGD regressor? What error, what loss function we use mainly? Anybody? Okay.
Mean square error.
Yes, the mean square error, right? And in the mean square error, the plot is something like this, right? The U shape mainly. and where we have the weights value here and the loss value, which is the function of j here, right? So here we mainly have to minimize this function using the gradient descent wave. So like mainly we have to minimize this loss value by reaching to an optimal value of w, right, of the each weight value. Similarly, something like that we have in logistic regression we have a log loss, okay, log loss function, error function. And how log loss is defined? It is differentiable, of course. I'm just writing in two parts. You can set it to as L, okay. L of x, not x exactly, L of y, you can say. All right, the y hat which we are taking. Mm, and the y as well as some other values, which is the okay, sorry, the z value. How it is defined? It is something like this: log of z. If the value is 1, like if the y hat is not the y hat, sorry, um okay, if the whichever the probability, okay, so let me remove this one as well, right. So that not, sorry, not the z value, uh, this value which we are getting here from the sigmoid value. Okay, let's take the sigmoid directly, okay. So that will not that will simplify this function. So it will simply take the sigmoid value, okay, whichever we get, and if the value is you can say okay, not exactly the value, the actual value, all right, uh, the actual value which is y. If y is 1, we take the log of that sigmoid, okay, and log in terms of base 2, all right. And if the value is 0, like for as this is a binary classification problem, so we are only considering 1 or 0, okay, then we take 1 minus log of sigmoid value, and that sigmoid basically returns sigmoid function is this function, all right, e raised to the power minus c, which has a range of 0 to 1, okay. So this is the function which we have, all right. And then simply, like, this is the log loss function which we take as error function in logistic regression. Then okay, uh, like if I simply plot the graph, are you all familiar with this curve? Anybody knows? Like, this curve is of which function? Okay, let me plot the inverse as well. Let's suppose we have this another graph which goes something like this. This is a function of e of x. The graph is of e of x. Am I right? This is an exponential graph, the above one, okay. And this graph is inverse of e of x, which is log of, mainly you can say, x, okay. So this is the graph of logarithmic, basically the log function graph. If I simply log function graph, if I simply show it, um, something, um, okay, um, all right, I think I'm doing a mistake in the function, I guess. uh, okay, it is, sorry, it is the there, sorry guys, some there is a mistake I have done, that is if the value is 0, then it takes 1 minus sigmoid value, all right, and then at the end it takes the minus of this, all right. Sorry, this is not the log of graph, this is minus of log of x. The log graph is something like this, right? This is basically the, you can say, the flip side, the mirror of that graph, right? The minus of log of x simply. Okay, so this is the log of x, which we minus log of x, which we can simply replace it via this one, this value. All right, and then we have like this minus one as well. So if we plot both these graphs, then we will get some kind of these. Okay, sorry, this as well as this. These two graphs which we will get if we simply like plot these two graphs independently, like these two functions, which is minus log of sigmoid and minus log of sorry 1 minus sigmoid. All right, so these two graphs which we get, and we may this with the help of these graphs we define our loss function, which is this log loss. Okay, and if you simply ignore these values like from this one, like at the intersection, if we only take this till this intersection value only generally, which we take, then we get some our graph something like this. All right, not exactly, something like this we can say. Okay, not able to plot. Yeah, now so this this we will get the graph something like this, which is like you can say L, which is the logistic log loss function plotted here, and these are the sigmoid values. All right, so the sigmoid value ranges from 0 to 1, and this will be the graph of it. Okay, so this is the log loss function graph, and then if you simply see, we have to do the same thing here, okay, which we do in the linear regression, which is we can apply the gradient descent to it, we can find the derivatives. All right, and then we can like we have to find the best. Okay, sorry, that is not the sorry, that is not the actual sigmoid value. um, okay, I think yeah, sorry, we have to mainly minimize this function, right? We have to okay, not this sigmoid value, sorry, these, this is not the sigmoid value, I think. Mainly like we have to yeah, sorry, this is the sigmoid value only. Okay, uh mainly what we have to do is we have to use the gradient descent here, and let's suppose our current sigmoid value is something like here. Okay, let's suppose you are taking the average. Okay, average of all the values, and you are getting something here. So the error is somewhere here, and we need the error like almost, we need to minimize the error. So we can do the same thing, the gradient descent way here, and we can like take some steps by like subtracting the derivative with some alpha values and all, and then we can reach some certain value which will be somewhere here. Okay, you can define it something like this. So whenever when we simply minimize this sigmoid value, which means we are minimizing this function, am I right? If we are minimizing this value, we are minimizing this function, right? Can I say this? Okay, okay, let me uh, a little bit mathematics, you can say. Let's suppose I have a function f of x, which is simply uh, okay, not x plus y. All right, then I have a function g of, you can say, g of f of x. All right, and this g of x f of x, which is, you can simply say 2x plus y. Okay, something, it is defined something like that, and we are considering this as the sigmoid. Okay, so if we are like mainly, okay, if we are minimizing this function, this sigmoid value, if we want to minimize this sigmoid value, which it means we have to minimize this function value, right? This value, can we say this?
Yes.
Right, and this function is based upon the f of x value. All right, so at the end what we are eventually doing is by minimizing this value, we are minimizing this value. All right, Can we say this? This is just, you can say, a simple chain rule as well. Okay, chain rule effect, which you can say, like while minimizing various functions. So the same thing is happening here. We are minimizing this sigmoid value, which is basically simply minimizing this function, and in this function we have this z value, right? And that z value is function of x, which is wx plus b. All right. So we eventually get into the same parameters at that is w and b, and like we guys, you all know like how to minimize that value, right? By taking, like, using the mean square error. So we again get back to the linear regression. So we are minimizing this value, which is this function, and this function is made upon this z value. That z value is f of x. Okay, and at the end we are minimizing this function. So that is why it called as logistic regression. Okay, so we have come too far. So is this understood? I know थोड़ा सा like काफ़ी ज़्यादा लग रहा होगा. You can watch it again. थोड़ा clear हो जाएगा. And sorry for that mistake in the function value. This one the plus.
Minimizing the logistic regression function turns into a linear regression function. Is it right? Is it that
Sorry.
minimizing the logistic regression function turns it into a linear regression function?
Yes. Yes. Under the need, we are simply minimizing the linear regression mainly, but we are like setting the value which we have, the loss function which we have, that is based upon this function, that sigmoid function. All right. So this is the difference. Okay. So this is which all the thing which we have in logistic regression. Uh, I may be not able to explain like very much clearly, but I think आपको main intuition तो पता, you will like, you all are clear with the intuition, like how, why we call it as logistic regression, okay, and how it simply works. All right, is this much clear?
Yes, it is clear.
All right, now let's move to the code. Okay. Okay, so we are getting this warning, that is fine. um, okay, so let me run these cells again because the session was like stopped. Okay, till now do you guys have any doubt? If you guys have any doubt, you can ask. Okay, so let me run this and all the other cells as well. All right, and at the end we got this exchange transformer which we got, right? We were at this, right? We have builded a transformer which mainly handles all the values, and we get this at the uh, transform data set to train into our model, logistic regression. Now I'm not going to implement the logistic regression right now because we have to cover this classification matrix also. This is some important stuff. Okay, so the main so like I'll just simply show you, mainly आप लोगों ने करा ही होगा, like how to basically create a logistic regression model, right? We can, as this is a linear model, okay, so it comes under the linear model library only. Okay, let me, yeah, linear model module only, and in the linear model we have this logistic regression. Okay, and one more thing, we have this SGD classifier which we can see. Okay, how these two are same, I'll just show you in a moment. Let me define a model, logistic regression, and I'll simply like do model dot fit xtrain tf, which is the transformed data set. Okay, and after that I'll simply pass the y values, y train. Okay, this is how model will fit, and the convergence warning which we are getting, that you can simply say model is converged enough, like it is almost new. Logistic regression is a non-linear model. Yes, that is a non-linear model, but its underlying definition is linear, right? We are going, logistic regression is defined based upon linear regression. Guys, आपको noise आ रही है पीछे से? Are you getting any kind of noise?
Yes.
Um, okay, sorry for that. Actually, साथ में function हो रहा है, I can't do anything. Um, okay. Yes. So like that is the convergence warning you can ignore, and then we have mainly fitted our model, and if we simply like we can use the model dot predict as well, like x valid tf. Okay, then we get some predictions like this. Okay. Then like model dot score, if you see, that is the main thing which we should check on. Y valid, that gives us some score in 0.76, something like that. Okay, what do you all think? Is this R2 score which we had in linear regression? Like, what is the metric behind it, behind the score? Anybody? um, any guesses you can in fact say, like, is this R2 or any other score? Like, it is in point, so of course it can be MSc as well. um, what do you guys think? Okay, what scoring function do we have here in the model dot score, like in this logistic regression by default? What scoring function do we have? R2. Okay. Anybody have any other like answer? Um, all right. So this is not R2. This is mainly sorry. This is not R2. This is accuracy. Okay. Um, I don't know if it is. Yeah, it is written. Returns the mean accuracy. Mean accuracy, accuracy, or it is the same thing, you can say. Okay, mean accuracy is simply dividing the like if we have multiple labels, we can also train the logistic regression based upon them as well. Okay. I'll give you a little bit of intuition about that as well on the logistic regression. So it is mainly accuracy. Okay. We will move into that for that also. I'll just simply show you this SGD classifier as well. Okay. So you all know, like in linear regression we have two kinds of basically underlying ways. First is the gradient descent way, which we have talked about here. All right, and the other one which we had is the normal equation way. Okay, the similar thing which we have, like sorry, here. And like if you want to use the gradient descent way, then you can simply use SGD classifier, and in the classifier just set the like it is like just set the loss as log loss. All right, the loss parameter. Rest everything that is you can say that is independent of this, mainly, not all, but yes, sometimes. Okay, then I'll simply do model dot fit x train tf and y train. Okay, so this is my model, and if I do model dot predict x valid tf, you can see I'm getting these values like in binary, not in the continuous variable. Okay, then if I simply check the score, x valid tf and y valid, you can see I'm getting the same accuracy which I was getting here. Okay, it doesn't matter which one we use. Sorry, the logistic regression is basically the same implementation as using the SGD classifier as log loss. All right, so both are same, just that you can use the same thing with in many different ways. Okay, then in the this, okay, sorry, it was modeled. Okay, sorry, it was model 2, it is model 2. And okay, so there is a difference in accuracy. Sorry for that thing, that called model by mistake. That difference in accuracy that you can handle via other parameters. Okay, you can do hyperparameter tuning and you can handle other parameters as well. Like if you set the same parameters which we have in logistic regression by default, then you won't get any difference in the accuracy metric. All right. Then one thing which I wanted to show you, which is predict log probability, mainly x valid tf if I do. Okay. Not the, I think it was predict probability. Yes. Yes. So you can see this is mainly probability values which we are getting here. Like for some we are getting 1 and 0 directly, for most mainly, and for some you can see we are getting like minus e2, like e minus 099. So it is like almost 0, but it is very close to 0, but it is not exactly 0. So these are the probability values. Like here also you can see 1 point something and 3.41 something. So yes, this is how you can get the probabilities values as well. Okay. This is like the main thing. I just wanted to show you how to use the logistic regression. आप लोगों ने mainly week 6 cover कर ही लिया होगा, week 5, week 6 and week 7, in fact 8 as well. So you all are like clear with that one as well. Okay. Now let's move forward to the classification metrics. This is an important topic. Like in regression we have various classification metrics, right? We have MSC, we have R2, we have MA, and we have RMSC as well. All right, and we have other metrics as well. We have like a lot of metrics. So this is in the regression, like for regression problem. All right. Then in classification problem, I'm simply writing C as classification. We have like some metrics, accuracy, the main metric which not the like the default metric which we can say accuracy. Okay, let me write it properly, accuracy. Then after the accuracy we have precision, recall, and some other metrics also based upon all these, F1 score and all the things. Okay. And most of the time it's better if we consider these metrics rather than the by default accuracy. Okay. Do you know like all these metric names earlier? Like have you heard them before? Have you all heard these names before, like precision, recall, F1 score and accuracy? Okay. Anybody knows why do we use like why it is mainly preferred to use precision, recall, F1 score, like these metrics rather than the accuracy? Anybody? Like mainly the reason. Accuracy is good. Okay, I think you said it. Yeah. Okay, yes, you're right. Accuracy is not good when data is imbalanced. How? Let's take the earlier example only. Okay, sorry for that noise. In recording there is no noise mainly. See, for the accuracy, I'll just go fast. Okay, the accuracy, let's take that earlier example, which is the heart disease prediction. Okay, we have okay, let me write it here. We had like we have 1000 samples. Out of those 1000 samples, 950 samples say patient does not have heart disease. Only 50 samples says patient has heart disease. Okay. So, and let's suppose we have trained some machine learning model and we are getting the accuracy as 95%. Okay, can we like, can you say our model is accurate enough? Anybody? Just say yes or no. Even you can add a guess. I just want the session to be interactive. Okay, no. Right, we cannot say. Why we cannot say? Man lo, just take an assumption that our model, like we have defined a model which is giving me all values as zeros. Okay, which is giving me all zeros, no one. Okay, there is no single sample, the predicted value which is as 1. Okay, so like we have 950 samples. Okay, and which are zeros, and only 50 samples which are ones. So if we simply check like all the 950 all the 950 the predictions uh, that are simply like zero. Like accuracy is mainly like checking, matching the values. Okay, there is no much kind of a difference. It will check the y value with the predicted value. Okay, it will simply match with the double equals, and if it is same, then it will increase the counter by 1. If it is not, then it will not increase the counter. Okay, let's suppose all the values are 0. So for all the 0 values, it has increased the counter till 950. And when we got the some 1 values as in y, then in y hat we obviously we had all the zeros, then it is not counting those values, and hence we are getting 95% as accuracy. Okay, so this is the main thing, and we cannot say based on this that our model is accurate enough. But instead, if like we are getting accuracy 96, 97, 98 or 99, something like this, more than the proportion of the target label, then we can say our model is kind of accurate, right? We can say, am I right? Just based upon the accuracy metric. Yes, and the same thing. That's why we do not, accuracy is not like being considered as a good metric. Okay. Then we have other parameters which are precision recall and F1 score. And before going into that one, let me like show you one important concept, which is confusion matrix. What is confusion matrix? Anybody knows? What is confusion matrix? Okay. Can you define it, Rishabh? Which be whatever, like what is confusion matrix? If anybody knows, you can. Okay, no problem. See, confusion matrix, first of all, ignore the name confusion. That literally gives subconsciously in our mind gives us like that is so confusing. Okay, matrix simply represent the 2 by 2 array. All right, or we can simply say a table, right, with rows and columns, where rows are like in this and the columns are defined here, right? This is a general matrix which we can say, and the confusion matrix is divided into 4 parts. Okay, that is row 1, row 2, then column 1, column 2. All right, and in the confusion matrix, what we have is yes, used to evaluate the performance of yes, metric of predicted and actual values. That is like in the confusion matrix. Okay, if I show you this sample, like this is what I have like simply copy pasted an image from internet. This is how a confusion matrix looks like. I know बहुत सारी चीजें हैं इसमें. Let me give you like in simply, let me simplify it for you all. So the first thing which we have is like all the rows we can say as the actual values. Okay, which means the actual y values. Okay, and in the columns we can say the predicted y values. Okay, predicted y values. And as this is a binary class, we are like talking about only binary classification as of now. So in binary classification we have like ones and zeros, right? Am I right? Okay. So then in the predicted values as well, like we have the 1 and 0, we are just assigning the labels for each row and each column. Okay, column 1 represents the predicted y values which are 1, and column 2 represent predicted y values which are zeros. Okay, and the row 1 represent actual y values which are 1, and the row 2 represents actual y values which are zeros. Okay, so this much clear to you all till now, this basic diagram? If it is clear, you can give a thumbs up. All right. Now let's move forward. Okay. If it will be good if I can pop it, so that will be kind of a step-by-step way. Yes, this is good. And what I'll do is it's in Facebook. Now see, just bear with me for a few minutes. बहुत easy है confusion matrix. Okay, first of all, forgot the name confusion. That will simply create the confusion. Okay, let's take a simple example with this. Let's suppose we have 100 samples. Okay, 100 samples and hence 100 y values, right? And in y values we have like ones and zeros. Okay, and let's take the classification, any kind of classification sample with email spam classification. Okay, email spam classification, and 1 represents that the mail is spam, 0 represent mail is not spam. Okay, I'm just marking it NS. Okay, and let's say in these y values, out of those 100 samples, the spam and not spam, the spams are, let's suppose we can say 60, and the non-spams are 40. All right, so this is how y values are proportionated. Okay, now this is what matrix which we had defined here, right? Here one basically represents the mail is spam, 0 represents mail is not spam. All right, okay, what is the value of row 1 based on this data? What is the value of row 1?
Would be true positive.
No. Row 1. No true positive. Don't go into that stuff. Just tell me what simply I'm asking. What is the value of row 1 will be? Like how many spam emails are there? Simply I'm asking the same thing. Either row 1 or either
60.
60, right? And what is the value of row 2?
40.
40, right? Okay. Now I'm going step by step, so don't worry guys. Okay, let me paste the screenshot again, let me zoom it. All right, now considering, okay, let's forgot that row 1 and row 2 as of now. Now let's suppose we have trained some model M and it gives us some predictions which are 100 values, of course. Okay, now we will simply divide them into spam and non-spam. Let's suppose it has classified them in 50-50 ratio. Okay, 50 are spam, 50 are not spam. Okay, what is the value of column 1?
50.
50, right? What is the value of column 2?
50.
Again 50. All right, so till now is this clear? Is this clear to you all? Just give me a thumbs up if it is clear. I'm just simplifying the confusion matrix as much as possible, so कभी भी आपको कंफ्यूजन ना हो. Sorry for the noise once again. So let me uh, paste it once again. Okay, so let's now get into this one. Now let me write those values once again. Row 1 is okay, let me get rid of, okay, I can't get rid of that one. So let's say row 1 we had 60, row 2 we had 40, right? Column 1 we had 50, and column 2 we have like 50. Don't I think I 50 like this. All right. So uh, if I could, I would have. Okay. So this much information we have till now. Am I right? Is this clear? Like I have just written all these in the same thing. Okay. Now, like out of those 60 samples, okay. Okay, these, sorry. Now just let me give you some name, give them some names as well. Okay. Let me define another confusion metric. Um, okay, not here in fact. Let me define somewhere here. And this. Okay. Here we have the actual y values, and here we have the predicted y values. All right, this we have, and now I'm simply writing, okay, positive. I'll simply let me write p here, okay, rather than positive, and let me write n here rather than 0. Okay, positive represents 1, negative represents 0. This is positive. Okay, I'm just naming these values. Okay, negative, and again here positive, negative. Okay, so here we have these, let me write it, r1 as 60, r2 as 40, r3, not r3, c1 as 50, and c2 as 50. Okay, now this is the confusion matrix which we have. Now let me fill in these boxes. How? Okay, first match, just simply it is the matching, it is basically finding the intersection in each row and column. Okay, we have 50 we have 60 positive values, okay, in the first row, and we have 50 positive values in first column. So how many positive values will be here exactly in this first row, first column? Just simply do this, 60 we have in total here, okay, and 50 we have in total here. How many will be here? Like a simple intersection problem. Consider there are no edge cases, just a simple assumption which we can say, like 60 is greater than 50, right? A simple mathematic, or you can say a simple assumption, like all the 50 yes, 50, right? The answer is 50. That is, these are like all the all the rows which are actually positive, all the samples which are actually positive are 60, okay, and all the samples which are predicted as positives are 50. Okay, so that means now I'll define some more definitions here. That means all the true positives, that means p represents positive, all the true positive value of true positive is 50. Okay, let me write it like that, true positive as 50. Okay, this much clear? the positive is matching, both positives are matching. Am I right? This much clear? Okay, now go to this negative. We have like seen, we have filled up the first row and first column. Now let's fill up the second row as well as second column. We have 50 we have 40 negative values which are actually negative. Okay, and then we have 50 values which are negative values which are predicted as negative. Okay, 50 values which are predicted as negative. Then in this second row, second column, this box, we can say as true negatives. Okay, these are true negatives which simply represent which is 40. The value is 40 here because this is simply the intersection of values. Okay, this much clear? All right. Now here comes a little, you can say, tricky part. इसमें मैं भी कभी कभी कंफ्यूज हो जाता हूँ इनफैक्ट. Okay. Okay, so before that, let me define what are like how I'm representing true and false. Okay, so we have true and false, and we are defining, like we are using true and false based on actual and predicted. Okay, like both of these are divided into two parts, which is true positive, true negative, and false positive and false negative. Okay, and it's just a combination of positive negative with true and false. Okay, these will be the combinations, right, with the true false and the positive and negative. Am I right? The combination of true false with the positive and negative. Like for each true we have two things, true positive, true negative. For false we have two things, false positive and false negative. Now just a simple thing, the values which are actually positive, okay, and predicted as positive considered as true positive. Okay, which means actual positive and predicted positives are true positive. This we have seen here, which is 50 in our case, right? And then let's look into the last one now. False negative, sorry, not the false negative, so the second one, true negative. True negative means actual negative and actual positive. Oh, sorry, predicted negative, which is 40 here. Okay, so true का सबको clear हो गया? Like this part is, I hope ये तो बहुत easy होगा, इतना सबको clear हो गया होगा. Now comes the main part, which is false positive. False positive simply represents the values which are simply not positive, which means they are actually negative but predicted as positives. Okay, which means actual negatives and predicted positives. Okay, false negative, no, you can't say false negative as that. Okay, false represent जो गलत हम कर रहे हैं. This side. Okay, ये clear है सबको? This one, false positive. Like mainly, like how do we conclude that actual negatives and predicted positive? Then we are left with just one last thing, which is actually positive, which are actually positive but predicted as negative. Okay, those are false negative. Okay, so that is the difference in false negative and false positive. Now just simply like fill in these values. If we fill in, we have like how many actual negative values we have? How many actual negative we have? 40, right? We have this actual negatives, and how many predicted positives do we have?
50.
50 here. Okay, not that 50, sorry, predicted positive, this 50. ओके सो ओके मैंने इसमें थोड़ा सा मैंने यहाँ पे गड़बड़ कर दिया आई थिंक yeah okay never mind I should have taken some different values okay no problem so uh, let's move on to where this one okay um uh this C is these are like this much is clear, true positive and true negative. Now let's fill up this one. Okay, this is basically representing what this is represent. Okay, the first row and the second column, what it is representing, actual positive and predicted negative. Am I right? And what are these? Like actual negative and predicted positives. um, okay sorry okay I think let me check this. Let me take the direct one, copy image and let me paste it here, that will be more clear. All right, so this is uh, the actual thing which we have here. Okay okay that is let me take another one, not this one. Yes, and yes मुझे जो लग रहा था मैंने वो कंफ्यूजन मैंने खुद ही कंफ्यूजन कर दी सॉरी this one okay so the false positive sorry the false positives are like mainly who are simply predicted as positive okay second word से we can identify मैंने किट simple trick अपने बस mind में बिठाई हुई है the second word we can take for the predicted okay the false positive represents means who are considered as positives okay but they are actually negative okay and the false negatives are simply which are predicted as negative but they are actually positives okay so वही confusion मैंने यहाँ पे कर दी थी now now simply actual negatives okay so we have okay let's fill in the false positives one. So this is the false positive how like we have the actual negatives and the intersection of actual negatives as well as the predicted positives which is basically like if you see 50 samples are here 60 samples are here then that means 10 samples are here which are okay let me remove that so 10 samples which are false positives okay not the false yes which are false positive so ये यहाँ पे false positive हो गए then we have the false negative which is actual positive and predicted negative so false negative again just check the match the negative with the that predicted y value and here if you see we have the 60 values here and 50 here so difference of these values is 10 okay and this we got here which is 10 and like this by this we have mainly created a confusion matrix and if you sum up all these values like the inside values you will get 100 which is the actual number of samples that is 50 plus 10 plus 10 okay sorry there is मैंने शायद कुछ पढ़ करी फॉल्स पॉजिटिव्स यहाँ पे कोई नहीं है yeah false positive and false negative these are 50 40 and the here let it's better अगर मैंने थोड़ी different values ली होती, थोड़ा सा mix up हो गया. No worries. So like we have all the positives here and all the predicted positives as well as our 50. So we have false positives as 0 because there is no actual y value like which is being predicted as positive. Okay, but here we have some 10 values, and if you sum up these values, that is 50 plus 10 plus 40 plus 0, we will get 100. All right, and sorry for that confusion. False positive here we have 0 for this case, and this is just a simple confusion matrix. थोड़ी सी confusion हुई. Should I give you one more example? This time I'll be just very fast. I'll
Yes.
simplify, define it. Okay. Uh, let me define the confusion matrix first. Okay. Here we have the actual values. Okay, positive, negative, predicted values, positive, negative. Okay, and let's suppose in the y values we have positives as 50, let's suppose, okay, sorry, 45, and negatives are like just simply take 155. Okay, and in the y hat we have positives and negatives as positives, let's say 60, and negatives, let's say 40. Okay, okay, let's go through one by one. What is the column what is the value of column 1 based on this data? Anybody, what is the value of column 1? Like, what are positive values? We have like 60 here, right? So that is 60, right? And the column 2 is 40, and similarly the row 1 is 45, the row 2 is 55. All right. Now simply let's just fill in the diagonals first, which is the true positives and the true negatives. Okay, first for the true positives, 60 values are being predicted as positives, but only 45 are actually positives. Okay, so what are true, how many true positive values will be?
45.
Right, 45 will be the true positive values. Okay, and now we have 40 values which are being predicted as negative, but actually in actual we have 55 values which are actually negative. So how many what is the value of true negative?
40.
Right, 40. You can simply do something like, if you take a small samples and you can create some balls, like if you do the counting, okay, with some values, then आपको पूरा clear हो जाएगा, ठीक है? Then here comes the important part, the false positive. Okay, so how to define the false positive and negative? Just simply look in the predicted part. Okay, जहाँ भी हमारे पास we have the positive as predicted, that respective its respective box will be considered as a false positive. Okay, and wherever we have the negative, in whatever column we can say we have the negative, that column is with the row considered as the false negative. Okay, now how many false positives do we have? Like 45 are actually positive, but model has predicted 60 as positives. So the difference in 60 minus 45 is simply 15. Okay, and that is the false positives. Okay, so okay, no problem, Vishal. Just so let me first clear this one, and yes, okay, now we again, like इस बारी थोड़ा और उल्टा केस हो गया. That is we got false negative as 0. Why? Because all the 40 samples are predicted as Okay, sorry, not 0 here. Sorry, not 0. I think मैं कुछ या तो confusion कर रहा हूँ. मुझे थोड़ा example अच्छा सा लेना चाहिए, so then it will be much easier. Okay, there is that should not be 45. Sorry, actual values are positive, so that whole row is positive, and out of those whole rows, so let's suppose I have the intersection values. I'm just simply matching, and here we get the 5. Okay, and that difference comes out to like 5. Yes. Sorry for the confusion and all. Okay, okay, let's check this one. So let's suppose we have 10 balls. Okay, let me take this direct example. We have 10 balls, out of which 6 balls are red and 4 balls are blue. Okay, these are, you can say, actual y values. Okay, and then we have y hat values, where we have like like here we have y values, and in these y values we have 3 red balls, and let's say sorry 7 blue balls mainly. Okay, so yes, so this is just a main thing. And if we simply look into this part, what this is being like, what do you call this? What will you call this box mainly?
True positive.
Yes, these are okay, let me use this marker. These are true positives. Okay, and okay, rather than that, मुझे थोड़ा सा और yeah, okay, this red and this is red and this is red. Okay, now it's fine. What are these 4 values? These are true positives, right? Let me write it. These are true positives. Okay, because actual are also red and predicted are also red. Now the second one, this these 4 values mainly. What are these 4 values?
True negative.
Yes, these are true negatives. True negatives. Okay, then these are the main values. Now okay, now let me mark this with the green one first. Okay, what are these and this value? Like, they are predicted as positive, but they are actually you can say sorry, that is also true positive. That is come under this. Sorry, these values. Yes. So what are these values? Who are falsely predicted as positive, but they are actually negative. These are sorry, these are false positives. Okay, false positives. How? Because these are predicted as positives. Okay, but they are not actually positive, so they are considered as false positives. Now we have this one. Let me mark it with not blue. Let me take this color. Yes. So this and these 4 values. Okay, these are actually these are predicted as negative, but they are actually positives. Okay, so this is false negative. So this is how you can see the distribution, right? Now you all can see the distribution, right? And this is like now if I plot it into confusion matrix, like this. Now you guys tell me, like in the actual this is positive, this is negative, in the predicted this is positive, this is negative. What is this one, this column? Like what is the, what we can say about this column? What is this column, this box identifies?
True positive.
Yes, these are true positives, and we have two true positives, right? And then true negatives. We have two true negatives. All right. So this much
I
is
think
clear.
true positive is 3, no?
Oh, sorry. Yes, yes, yes. True positive is 3. We have 3 true positives and 2 true negatives. Then let's come to the false positives. Now these are false positives, like which are predicted as positive, but they are actually negative. Okay, so positive of this predicted match with this, the like wherever we get the positive in predicted, uh, that respective box, uska jo respective box hoga, that will be called as false positive. Okay, where we have actual negative but are predicted as positive, that will be considered as false positive, which are two here. And then false negative again, which are predicted as negatives but actually like they are positives, and these values are 3. So this is a confusion metric. Okay, and थोड़ी सी confusion इसमें भी predicted and negative में you can simply like use this thing, जहाँ पे positive होगा ना, that row will be considered in the positive only. Okay, like if I show you, whenever you get some question of confusion matrix, simply create a box. Okay, the first step is to create a box and mark the respective columns and rows. Okay, so actual and predictive, positive, negative. Second thing, uh, uh, with the column with the having the positive predicted values, mark them as like the positive, like the true positive, false positives. Okay, and same for the negative column as well. This is false negative, this is true negative. Okay, and then simply fill in the values. So this is the certain simple thing, and these values will be given in the question, like which are marked as positive but are actually negative, and so on and so forth. So this is how you can simply construct a confusion metric. Like then you can simply, by looking into the data, you can simply fill in the values, and you can see I'm getting the 10 as answer, which is the, like if we sum all these numbers we get 10, which is the actual number of balls we have. Now is it clear, the confusion matrix? uh,
Can you once show previous example where, yeah, this one.
okay. Here actually like we don't have the exact data now, so that's why we are not able to identify mainly. Okay, here we have the exact data, and the same thing we have when we are when we call the confusion matrix function, or when we manually calculate with the help of loops and all, then we have the exact data, right? So based on that we can create a confusion matrix. By looking at number of samples we may get confused, but if we have the exact data, then we can simply identify like which are the true positive, which are the true negatives. Okay, so this is like the confusion matrix, and based on this confusion matrix, uh, okay, one thing, uh, only now based on this confusion metric, if I remove this one right here, confusion matrix. Okay, based on this confusion matrix we got three mainly three metrics, which are accuracy, sorry, precision and recall. Okay, accuracy is simply actual divided by the total number. Okay, So what will be the formula of accuracy based on this? Okay, what is the accuracy of this confusion matrix? What is the accuracy of our model, which you can say? What will be the accuracy? Like true positive, just look at the true values or simply the diagonal one. Okay, that gives us the accuracy. Like true positives are 3, true negatives are 2, so that is 5, and total samples we have, so 50% is the accuracy. And the same we can define via these values as like this: true positive plus true negatives divided by true positive plus true negative plus false positive plus false negative. Okay, so this is how accuracy is being measured. All right, so we take all the values in bottom and only the true values at top, and this is how accuracy is being measured. You can see accuracy is 50%, right? Because we can only identify few samples as correct. Am I right? Okay. Then we have the precision and recall. These are like some important, you can say, and these two helps us when we have imbalanced data set. I have written here regarding the precision and recall. Precision is basically out of all positive predicted, what percentage is truly positive. Okay, that is okay. Let's look into this itself, this confusion matrix. Based on this confusion metric, like the definition is out of all positive predicted. That means this column, how many are actually positive, which is this true positive. So can you tell me its formula, predict the formula of precision based on the definition and this metric? I think it will be easier to check. Can anybody? Okay. Let me show you by this example only. See, this is the confusion metric which we have, and basically precision जो है वो predicted positives के base पे calculate होता है. Okay, so we will consider this column only, this column 1. We will consider this column only, and out of this column, how many are true positives? We just have to check this. That is the formula of precision is true positives divided by true positives plus false positives. False positives. Okay, this is how precision is being calculated. Okay, and then we have recall. In recall, the formula is just you can say transpose. Okay, in recall, it is based upon this thing, like how many of from actual positive values, how many are actually predicted as positive values. Okay, out of total positive values, what percentage are predicted positive? So that is, you can say, the opposite of precision. Recall is the opposite of precision, which means true positive divided by true positive plus false negative. Here the base is predictions. Okay, predicted positives, and here the base is actual positives. Okay, that you just need to remember, and rest precision and recall आपसे हो जाएगा. Okay, so are you all clear with these three definitions: accuracy, precision and recall? Okay, all right. So this is like how precision and recall is being calculated, and rest you can check this diagram as well. Okay, here you can see recall is basically the total positives, and that is this row, how many are actually positive, how many are predicted as positives, and in precision, out of those who are predicted as positive, how many are actually positives. Okay, and now just a simple question, like if we get back into that heart disease problem, we had 95% accuracy, 950 samples and all. Which metric is best, accuracy, precision or recall? Like for imbalanced data set, that like we had this proportion, right? This is for the negatives and this is for the positives. And then which metric is better, accuracy, precision, or recall? If anyone you have to choose, then which one will you choose? Okay, precision. See, accuracy is not good, okay, because it won't check the imbalance things and all. Now, predicted positives. So, predicted positives and actual positive, the precision and recall, both we can say are like the better metrics, okay, for the this kind of problem, the where we have very imbalanced data set, but like mainly we are identifying a very rare condition. So it's better कि जो हम जो है actual values को basis माने, ठीक है? So that will be more better, we can say. Then we can say our model is how much accurate. Don't consider accurate as don't consider these same thing, accurate and accuracy as same things. I'm just saying, like, when we have some kind of rare disease that, or some kind of we are doing some very important prediction which mainly cost us in different means, like in financial terms, in mental and physical way, then our recall is much better because we have the basis as the actual values, okay. And based on actual positive values, that means हम सिर्फ इन 50 samples को ही basis मानेंगे. All right, am I right? कुणाल, श्रुति एंड नंदन, लाइक जब हमारे पास बहुत रेयर डिसीज होगा, देन इट्स बेटर कि हम जो है, जो जिसका कम प्रपोर्शन है, जो मेन थिंग विच वी हैव टू प्रिडिक्ट, वी शुड कंसिडर दैट एज द बेस. सो दैट्स वाई we should consider recall as the base for these kinds of problems. All right, it doesn't mean कि हम precision को नहीं मानेंगे. Sometimes precision ज़्यादा हो सकता है कि जब हमें predictions को ज़्यादा like importance देनी है, like when we don't have that kind of severe consequences, but our data is not that much proportionate, okay. Like when we have to check how much our model is efficient or are accurate, then precision is much better metric, and then we have the recall, okay. So based on this, so this much is like precision and recall. Now based on these two metrics, we have one more metric which is F1 score. What is F1 score? It is simply harmonic mean of these two metrics, okay. F1 score, or even if you get somewhere like harmonic mean, to calculate the harmonic mean, given this is the precision, or and this is the recall, then you have to find F1 score, that is the harmonic mean. Harmonic mean का formula simply क्या है, that is okay, let me check once. मैं ऐसा न्यूमरेटर और इसको डिफरेंट में लिख दूँ. F1 score formula, precision into recall, yes, I was right. So in harmonic mean we simply sum the things, right? So we will simply sum the precision and recall, and in the numerator we will simply multiply them with the two, precision into recall, okay. And this gives us you can say a weighted value. तो इससे जो है, मतलब अगर हमें दोनों मैट्रिक्स को कंसिडर करना है, तो दोनों मैट्रिक को आप डिफरेंटली बार बार कंसिडर करोगे, लाइक डिफरेंट मॉडल के. मान लो यू आर सेटिंग, यू आर डूइंग हाइपर पैरामीटर ट्यूनिंग, और लाइक you are having various models, various data sets, and you are getting different precision and recall values, and then you have to simply check for the like the main metrics are precision and recall. Then आप दोनों different metrics को compare करने की बजाय बार बार, what you can do is you can compare the F1 score, okay. That is a much better metric because that includes both the precision and recall values. All right, so that is why F1 score is majorly being used, like in the industry, is used in industry normally, but compared to accuracy, okay. And precision and recall are the basis, and confusion metric is the basis of all classification metrics which we have mainly. So this is all about this stuff, okay. So is this clear to you both? Kunal, Shruti? All right. Uh, okay, can we do a little question if you want, just a 5-minute question?
Yeah.
All right. Just a mainly to practice. So we have y values, y hat values. Okay. Uh, I will have some red values. I will take only 10 samples. So let me write it here as well. 10 samples and uh, yes, y value. 3, 5, and 3, 5, and 8, and 10. All right. Now let me create the confusion matrix. We will simply go one by one. So जिससे जो है हो जाए confusion ना रहे कोई भी. This is the confusion matrix, and we first plot the actual, label them with the actual, which are positive and negative, and here also positive, negative. These are predictions. Okay, predicted values. Now, okay, let me define. Red are positives and blue are okay. Blue are negatives. Let's suppose this one. How many true positives do we have in this one? Um, yes, 1 and 2. We have 2 true positives. And how many true negatives do we have?
2.
Yes, 2. Then false positive कहाँ पे आएगा? This or this?
False positive. और नीचे
यहाँ पे आएगा
yeah.
या फिर यहाँ पे?
False positive 1 पे.
All right, yes, 1 पे. Because false positive is basically match the p with this one and then the false positive here and here the false negative. What is the value of false positive? Who are predicted as positive, that is, who are predicted as red but are actually blue. I have marked one already.
3.
1, 2, 3, right. And the rest is obviously that will be 3, which is this, and this one, right? So this is
Yeah.
our confusion metric. What is the accuracy?
Accuracy.
4 by 10, which is 40, right?
Yeah.
And now precision is this. Okay, tell me the formula, precision formula.
TP plus FP.
Right. Precision is basically we take the predicted positive values as the base. Okay, so TP plus FP. So that will be 2 by 5, right? And then what is the recall?
TP by
Mhm.
TP plus FL.
In recall, we simply take the actual predict as actual positive values, and again we get the same 2 by 5. Okay, here both are same values, so we can say like how much our model is inaccurate based on this. The lower the value, the lesser the model is accurate, and obviously all these are measured in 0 to 1. Okay, and then the F1 score is simply based upon this precision and recall that you can calculate further. So now is the confusion metric this stuff clear?
Yes.
And Kunal? Okay, that is good. Well, end तक आप दोनों ही रहे, but I hope मैंने आपको ये evaluation metric clear करा दिए होंगे completely. कोई confusion है आप दोनों को? Kunal, do you have any confusion? Welcome. Okay, that's good. बाकी what you guys can do is simply आप ऐसे ही example लो in your pen and paper and try to build 2-3 confusion metrics. Okay, आपसे पूरा clear हो जाएगा. Rest, you both are in MLP group, right? I will do some polls in the MLP group regarding this confusion metric and उससे भी थोड़ी सी confusion clear हो जाएगी जो भी है. All right.
Okay.
So this is the main thing for this, like, to cover up the today's session. And like, we have, like, in the week 6 they have covered the confusion metrics to positive, false, negatives as well, but they have not explained it very well in the week 6, but they have explained it in detail in the week 9. Okay, and that's why I said, okay, we will cover some part of week 9 as well. So 50% of week 9 is completed by today's session, and the week 6 is week 6, and almost week 7 is covered by today's session. In the next session, like, I will just show you, I will give you a simple overview of all the other these classification algorithms as well. Okay, because अभी बहुत ज़्यादा हो गया, अभी अगर if we cover so सारा mix up हो जाएगा, and that I don't want. So it's better that we will do that the next session. All right. So do you guys have any doubt in anything which we have covered, or anything till week 8? Okay. Okay. And Kunal, do you have any doubt? Sure. Okay, no problem. Okay, so that's it, guys, and thank you for staying in the session till now. I hope आपके most of the concepts clear हो गए होंगे जो जो आज हमने पढ़े. So thank you for staying till now.